already learned about ABS system. To get a solution for rear wheel optimum braking, automotive engineers has already tried first proportioning valve and second LSPB in the braking system, but both are failure to give us an optimum braking at the rear wheels with a balance to the front wheel according to driver requirements. So that's why EBD came. So let's have a look. Why not proportioning valve? Some earlier automobiles equipped with ABS had the proportioning valve installed. The P valve reduces rear brake force according to hydraulic pressure produced in the master cylinder. As hydraulic pressure applied to the rear wheel cylinders doesn't depend on the weight loaded on the vehicle, so rear brake force becomes less effective when the vehicle is completely loaded. The hydraulic control in the past automobile therefore is far from ideal. Why not LSPV? LSPV enables brake system to obtain an adequate rear brake force according to the weight loaded on the vehicle. As shown on the graph, the split point varies with the load sensed by LSPV spring located on the rear axle. But as LSPV control hydraulic pressure mechanically, the gradient of the characteristics curve is constant, which makes it impossible for actual curve to match the ideal curve. So now we will have a look on EBD. As an add-on logic to the ABS-based algorithm, EBD works in a range in which the intervention thresholds for ABS control are not reached yet. EBD ensures that the rear wheels are sensitively monitored for slip rate with respect to the front axle. If slip is detected, the inlet valves for the rear wheels are switched to pressure hold to prevent a further increase in pressure at the rear wheel brakes, thus electronically producing a pressure reduction function at rear wheel brakes. ABS features an enhanced algorithm which includes control of the brake force distribution between the front and rear axles. This is called electronic brake force distribution. In an unloading car condition, the brake efficiency is comparable to the conventional system, but for a fully loaded vehicle, the efficiency of the EBD system is higher due to better use of rear axle braking capability. Effect of EBD on braking distance. While brake is applied not so hard as to active ABS control, brake force is proportionally distributed between front and rear brakes to prevent rear wheels from being locked too early for better stability of the vehicle. So, the objective of EBD is to control rear brake force to prevent rear wheels from being locked and to obtain minimum braking distance according to weight loaded on the vehicle. EBD operation. ABS and EBD system share common hardware. Front and rear wheel speeds are detected by front and rear wheel speed sensor respectively. ECU calculates difference between front and rear wheel speeds, then reduction needed in rear hydraulic pressure is estimated. Finally, optimum pressure is distributed to rear wheel cylinders. Combined working of ABS and EBD. The biggest difference between EBD and ABS is the threshold values. When the difference between the vehicle speed and wheel speed is larger than EBD control threshold, EBD control is implemented. In this control, rear outlet valve is opened only for a short moment and rear wheel speed increases a little bit. As the weight loaded on the vehicle becomes heavier, the rear wheel deceleration becomes smaller. This means that a bigger brake force is needed to extend EBD control threshold. In other words, a bigger brake force can be applied to the rear wheels when a heavier weight is loaded. If the difference between the vehicle speed and wheel speed becomes larger than ABS control threshold, ABS control is implemented. In this control, rear outlet valve is opened for a longer period than EBD control and wheel speed increases fast. So now we will see at the EBD application in practice. A car with driver on board carries the weight of the engine and transmission over the front wheels. This means the front wheels have the better grip than the rear wheels. Because the front wheels has more better grip, giving more braking force, result in shorter braking distance. But when the passengers and luggage are added, the load also added on the rear wheels. So the braking power must be evenly distributed in front and rear wheels. Speed sensor measures the weight distribution between the front and rear wheels. When the sensor detects any additional load at the rear wheels, it instructs the ECU to distribute the brake force more at rear wheels than the front wheels. If you see in practice two vehicles with fully loaded running at road 100 kilometers per hour, one equipped with EBD and the other is without EBD. When the both drivers apply the brake from the same point, but the vehicle with EBD will stop in considerably less distance than the vehicle without EBD. It is only possible because of its brake force is optimized based on weight distribution. EBD saved the vehicle from accident by reducing its stopping distance. The benefits of EBD: elimination of conventional proportioning valve and LSPV. EBD utilizes the existing rear axle wheel speed sensor to monitor rear wheel speed and slip rate. The second advantage is that, based on many variables in algorithm, a pressure hold, increase or decrease pulse strain may be triggered at the rear wheels, ensuring vehicle stability. Third, vehicle approaches the ideal brake force distribution front to rear. Fourth, EBD function is monitored via ABS safety logic, which cannot be possible with conventional proportioning valve and LSPV.